Hello everyone, welcome you to a new subject, that is engineering mathematics. Code is EEE610. So my name is Dr. Bilal Khan, and I'm going to teach you this course. So the basic idea here is that in this course we will look at the tools and techniques used to solve the real-time problems. So this is very handy, that help us to work with physical system and also to develop concepts and apply in research work as well. So basically we will look all the possible techniques that we can use to solve engineering problems. So there's a link available on the on here of YouTube, which will provide all the videos related to this lecture. Now, if I look at the contents, we have divided into ordinary differential equations that really help us to model the lumped uh, dynamic system, real-time dynamic system. So we use ordinary differential equation to do that. So we will look here how we model it, and then we also look at how we can solve these differential equation and interpret the output from these equations. So after that we will look at some linear algebra and vector calculus. So we need some formulations when we, for analysis, we need linear algebra. So we look at some concepts that involves linear algebra and vector calculus. So normally when we have a distributed system, so then we have we are normally use partial differential equation. So then we discuss what is Fourier analysis, how we can use to solve partial differential equation, PDEs. So after that, in some analysis we need some complex analysis. So we will move on to how we analyze system in terms of complex analysis. So after these analysis, to do all these solution analysis, we normally use numeric analysis, because there's a very rare chance that you come up with a mathematical modeling and you know the exact solution. So in that case we normally use softwares, and software normally utilize the numerical analysis technique to solve your problem. So that's why we have to use this numeric analysis techniques, and we will look into it, what are the tools and how we can use it. So after that, there's another concepts and tool that really help us is optimization. So we will look at how we can optimize our solution. So, and we also look at graph theory, that also work for distributed systems and different representation of the system. So that's why we will discuss these topics. So up till now we normally deal with deterministic systems, but normally you will uh, have some stochastic processes or random processes. So in that case you need some other analysis, or you have data available and you need to analyze the data from the system, instead of you have some physical system equations available, so you have to work with data. So in that case we need some probabilistic and statistics. So that's why, so these are actually few tools in mathematics that use a lot in engineering for designing, modeling, analysis, and also these help you to do and formulate your own research oriented problems, and also identify their solutions. Now, first part that we will start is ordinary differential equations, ODE. So we will look at what is ODE, basic materials, and then we look at some solutions, and then series solutions that we use in ordinary differential equation. After that, we will look at Laplace transform that help us to solve these ordinary differential equations. Now in part B we will move to linear algebra and vector calculus, where we discuss very scratch from matrices, then how we represent linear systems, and then vector differential calculus, how we use it. So normally we use a lot in communication systems. So how we formulate this, and after that we will look at eigenvalues problem that use a lot in control, machine learning, and also analyzing channel modeling. So that's where we use this eigenvalues. And then we will have to look at vector integral calculus that's we normally encounter in different engineering problems. Now in part C we will jump to Fourier analysis and look at how we go about partial differential equations. Now part D we will start with complex analysis and potential theory. We discuss some basic materials and a bit detail on potential theory. Now part E is basically about numerical analysis. So we discuss numerics in general, then numeric linear algebra, and then numerics for ordinary differential equation and a partial differential equation. Because when you do the modeling or you have some mathematical formulation, so either for especially for dynamic systems, so either you have ordinary differential equation, or if you have a distributed system, then you have come up with partial differential equation. So in that case, how you solve these equations? So we will look at what are the techniques used to do that. Now in part F we will move to linear programming in optimization and graph theory, and look at in general how optimization is done and what are the techniques used to solve those optimization problems. Then in last part G we will start with probability and statistics. So actually when you have a data, so these days a lot of work on data. For example, if you are in communication channel modeling, you have data. If you are doing in machine learning or in vision or deep neural networks or any other, you have a lot of data. Or if you have to work in characterization of the materials, you have data. So how you analyze the data? So what are the techniques that you can use to for analysis? Then we will discuss some probability theory, how we use probability theory for stochastic processes, and then we look at mathematical statistics, that when you want to do analyze the data, how you can do it using statistical tools. So these topics are in detail covered in a book titled is Advanced Engineering Mathematics, Erwin Kreisig. So this is website is available. So if you have this book, it will cover all these topics, and I am also following this book for this particular subject. So this really help you to uh, to get the idea or do some further reading and clear your concepts. Now, question is why you want to study this course. So, look at the importance of this course. So, first one I discussed earlier is the mathematical modeling. So, physical system mathematical you need mathematical formulation. When you have a mathematical formulation, then you need how to solve that mathematical formulation. So after that you have to need interpreting the solution. So that really helped you the subject to understand these basic concepts. After that we have judicious use of power software for numerical analysis. So um, uh, normally in engineering and industry we have involve a problem that are large when we do modeling, and it is also very complex, so with hundreds of equations or even more. So in that case we need some softwares to solve this. So that really help us to understand uh, and identify that which software we have to use and how what type of result we are getting from these softwares. So the another thing that is the beauty of engineering mathematics is that So you have relatively few basic concepts and involve powerful unifying principles. So this is important that you must know this idea, how you can apply these principles to different problems and get the solutions in engineering. So to clearly identify the concept and structure of the subject matter, so this is another important concept. You know that you identify a new problem and you know where to put in right group of problems. So what type of problem this is we have similar to this problem, we can use that techniques to solve it, model it. Second is absorb new information more rapidly by being able to fit into the conceptual structures, and also you have to develop the knowledge of conceptual mathematics. So for that case we need some software. So you can use any software. You have start from MATLAB to Mathematica and Mapples that can use to solve these problems. So you can I can give you some problems. You can use any of these softwares which is familiar with you. So if I look at how you are grading this course, so course grading, so actually we have minimum 4 assignments, so that includes 25% of the course grading. So uh, we can have more than 4 assignments, but at least 4 assignments are given to you. That's based on the knowledge is delivered in the subject. After that we will conduct a midterm examination, that is mid of the semester. So normally in 16 or 15 week of the session. So in that case you have 25% marks for midterm. So these 25 of assignment and midterm involves 50%. So after that at the end of the semester we have final examination, and that includes the 50% mark. So this total make up to 100%. So this is main assessment that is done in this course. So you have to know that the passing criteria is greater than or equal to 60%, and you must know that you normally save when you are around 70% in this course. So this is what is all about this course, and today we have first lecture. So I just give you an overview, so you can ask me questions during live session we conducted. So thank you for listening.